Hi there, thank you for joining me. I'm just going to make a quick short video about digital elevation models. Within this video I'm hoping that we're going to learn how to hydrologically correct a digital elevation model and derive some hydrological data sets like flow accumulation, flow directions, and some stream networks. So this digital elevation model has been freely available. It's a 90-meter resolution, and you can get it from the SRTM website. But it's important to keep in mind that sometimes when you download this data, they come up with some errors or some problems, if I may say. Mostly what you get with digital elevation models is some artifacts, and you tend to get some sinks, which they aren't really sinks. Actually, they're just some errors that might have occurred during the collection, or maybe the interpolation technique that's been used for the creation of the elevation model. So what we are going to do first is to hydrologically correct the data set. Make sure you do have your Spatial Analyst Toolbox turned on. You can do that from the Customize extensions, and make sure it's turned on here. I do have mine turned on, and I'm just going to use the search bar. It's very much quicker for me to use. I'm just going to type in field, and here we go. You have the field from the Spatial Analyst Toolbox, and what you need to do is to drag in the digital elevation model and put it in. And I'm just going to let it go to the default geodatabase, and I'm going to rename it to DM_field, and every other thing is going to be left as default. And I click on OK, and here it's completed. If we just quickly visualize these two different elevation models, we don't really see that much of a difference, because it's not really meant to make any much difference. What it really does is just correct the DM. If there are any sinks which aren't really sinks, it tends to fill it out all, and your digital elevation model is ready to go. And the next tool I'm going to use is the flow direction. I'm just going to type in flow direction. Here we go. And you bring in the flow direction. What this tool does, it takes the digital elevation model and creates a new raster model of flow direction of the directions that water flow to on the surface of your DEM. So I'm going to put in the digital elevation model, let it go to default geodatabase. I'm going to rename that to DM_FD for flow direction. Leave every other thing as default. Click OK, and hopefully that shouldn't take that long. Yeah, 2.6 seconds. And here we're going to have a new raster data sets that have been color coded for us already, and it does have this number that's been classified 1, 2, 4, 8, 16, 32. All of this number means different directions of the flow. If you go into the flow direction tool and you go into tool help, you will see a better description of what these numbers means. They all means different directions. Some are going to the north, some are going to the west and to the south. With this model you can be able to determine stuff like surface runoff within your study area and other things like that. And the next tool I want to use is the flow accumulation. Here we go. What the flow accumulation does is it takes the flow direction raster and it calculates the pixels that do have the highest number of pixels that are flowing into it. So it actually just calculates basically the areas or the pixels with the highest amount of water accumulating within that area. I'll let it go to the default geodatabase, rename it DM_FA for flow accumulation, leave the output type as a floating point, and run. Hopefully this shouldn't take long. 4 seconds. Good. And here we go. And what the highest number here tells us, 60,813. It means this area, the white areas basically are the areas with the highest amount of accumulating water within the study area. And what I want to do here is create a stream network from this flow accumulation raster dataset. And one way of doing it is to play around with the symbology and the classification techniques. So what I did was just sorry, too fast. I double clicked on the digital elevation model, the flow accumulation I just created, and it invoked up this layer properties window. And I go onto the symbology tab and go to classified, and go into classify and take the classes down to 2. And what I do is I start playing with this number from, let's say, 1000 and see what it looks like. I'll take 0 to 1000 to be not anything relevant in terms of stream networks, and whatever starts from 1000 to the highest number, I want to see it as a stream network. And here we go, this is what I do have. So all these pixels, the pixels are ranging from 1000 to 60,813, and I want to consider this as my stream network within my study area. But the thing here is I do not have this as a permanent layer. I'm only reclassifying the flow accumulation raster. So what I want to do now is to use the Raster Calculator to help us create a new Boolean raster model of a stream network. So what I'm going to do is I'm going to use a conditional tool. What I like doing here in the raster interface is to just punch into the keys and to the layers rather than typing it in, because it's a very sensitive tool here we do have. So I'm going to make a conditional statement. I'm going to say, please GIS, give me all the flow accumulation pixels that are greater or equal to 1000. If this is true, give me back 1, and if it's false, I don't want to know about it, so just give me no data. And I'm going to let it go to the default geodatabase. I'm just going to rename it stream_net. Keep it short and click on OK, and hopefully this should give me a new raster data set with just the stream network. So now I do have my flow accumulation raster, my flow direction raster, my hydrologically correct digital elevation model, which I use the fill tool on, and finally now I have created a stream network layer. So thank you very much for watching. If you do like this video, please like below.